Hey everyone, this video is basically about vocabulary and examples of a conjecture, inductive reasoning, and counterexamples because we're going to be starting our geometric reasoning. So a conjecture is an unproven statement that's based on observations. Inductive reasoning is when you look at specific cases like this one here. You have 1, 2, 3 figures, and then you want to write a conjecture for the general case. And a counterexample is when you prove that your is a specific case where you give an example where the conjecture is false, and that's what the video is about. And a lot of it is just vocabulary. So for this first one, if you look at figure 1, 2, 3, we're going to make figure 4, and the conjecture being, or our inductive reasoning being, we divided this figure 2 in halves, figure 3 in thirds, so we'll divide figure 4 into fourths. So 1, 2, 3 fourths, and then draw one line here and then shade here. So that would be figure 4. And if we do figure 5, our conjecture is you divide by the figure number. So here's figure 5. We're going to divide this into fifths. So let me see if I can do this. 1, 2, 3. Good, I did it. All right, and then you go do that and shade the corner piece. So your inductive reasoning tells you that's how you do it, and that would be figure 5. All right, and so you write your conjecture here, and then this would be the fifth figure that we already did. Here's another thing that we're going to look for inductively. We have a pattern, -1, -4, -16, -4, and we need to write the next 3 numbers in the pattern. So what we notice is that each number in the pattern is 4 times than the previous number. So you kind of do this thing and figure out that it's times 4 each time, so we can do the next 3 numbers. Again, the 3 dots tell you that the pattern continues. So those are called line dots. Dot, dot, dot. Right. The next example we have is we've given 5 non-collinear points. Remember that collinear means they lie on the same line. So non-collinear means they don't lie on the same line. Right. We make a table and look for a pattern. And you notice that they increase. So at 1 point, we have 0 connections. At 2, we have 1. At 3, we have 3. At 4, we have 6. So we have to figure out 5. So if you look at your differences here, you get 1 plus 2 plus 3 plus 4. Then the next one would be, if you keep going on, plus 5, plus 6, and so forth. These are called C dots here. All right. So since we have at 5, that's going to be 6 plus 4. So this would be 10 different ways. All right. And let's try the next one. If it was 6, and I'm not going to draw it, but if this was 6, all right, then you would add 5. So 10 plus 5 would be 15. And you keep adding like that. So that would be 15 different ways. And again, this video is just about noticing patterns. We notice that this pattern here is increasing by 1.5. And you could keep going on and on and on. All right. Now, we're going to make and test a conjecture. So, numbers such as 1, 3, and 5 are called consecutive odd numbers. We're going to make and test a conjecture about the sum of any 3 consecutive odd numbers. So what we know is we have 1 plus 3 plus 5 is 9, and that's 3 times 3. 3 plus 5 plus 7 is 15, and 15 is 5 times 3. So then we do another set. 5 plus 7 plus 8 is 27. So what we notice, or 21, what we notice is that we keep multiplying by 3, and we also keep multiplying that 3 by this second number. All right? So this is your conjecture. And then what you have to do is test that conjecture. And so we do another set. I'm multiplying by 3, the second number. I'm multiplying this by 3 by the second number. So that's just pattern recognition. All right. Make and test a conjecture about the sign of the product of any 4 negative numbers. And the result of the product of 4 negative numbers is always positive. So we could make another one. We have 4 negative numbers. So -1, -3, -2, -1, or -2 again. So that's 4 times 3 is 12 times 1. So that would be 12. That's positive. So you made and tested the conjecture. Here's our test. And it still is positive. All right. The student makes the following conjecture about the differences of 2 numbers. So his conjecture, hers, is the difference of any 2 numbers is always smaller than the larger number. So the difference of 2 numbers, that means A minus B. Let me do this. A minus B is always smaller than the difference of 2 numbers is always smaller than the larger number. So to find a counterexample, you need to find a difference that is greater than the larger number. So if we let 8 minus a -4, that equals 12, but 12 is not bigger or smaller than our bigger number. So let's pick a big number. 5 minus a -2. So our bigger number is 5. Well, this equals 7. So our 7 is not bigger than 5. And here is a scatter plot. You can look at it. It looks like when you do the best fit line, that it's always increasing, a positive correlation. So you could do a conjecture that the average player in the NFL is earning more money today than in 1999. That would be your conjecture. So the average, so basically give an explanation that supports your reasoning. To support your reasoning, the average salary of an NFL player in the future years will be higher than the previous year. So the average salary of an NFL player increased for the 5 years from 1999 to 2003. So you could kind of look that up and test it. And finally, we have this one. It says, find a counterexample to show that the following conjecture is false. So the conjecture is the quotient of two numbers is always smaller than the dividend. So this is the quotient, and it's always smaller than the dividend. So we could do another one. Let's do 5. Black. Let's do black. 5 goes into 13 2 times. So that would be 10. And you subtract and you get 3. And this is the remainder. So this number is smaller than 5. However, when you look at this, we're going to show a counterexample of why this conjecture is false. Because you have 4 divided by 1/2 is 8, and 8 is bigger than our two numbers. And just want to bring this up. 4 divided by 1/2 is the same as saying 4 times. Remember, you keep, switch, and flip to the reciprocal 2, or 2 over 1, which equals 8. And that's it. Thank you. Have a nice day. Bye-bye.